So the particle is projected at an angle of 30 degrees from the horizontal at initial velocity 7 meters per second. And I've got to basically find the equation of trajectory. Right, so I'll set this up as usual with the horizontal side and the vertical side. And I will use Stuva, it seems to be quite a popular one, and Stuva over here. And I've got to work out the equation of trajectory. It tells me that is the x-axis, and that's y. So therefore, the y vertical is going to, the vertical distance will be y, horizontal will be there. We've obviously got initial velocity horizontally, it will be 7 cos 30, and that won't change at all. That will still be 7 cos 30. There's no acceleration there. And on the right hand side, the acceleration, we've taken y to be positive upwards, so the acceleration will be minus 9.8. Initial velocity is 7 sine 30, and that don't care about. And I have to have a link of the time between the vertical and horizontal. We want to get y equals, because that's the equation of trajectory. We get y equals, so I'm going to end up over here. So I want to work out t first over here. So I want the one, well, I could use other things, but I'm going to go for u, s equals ut plus a half a t squared. And that will say that s, which is x, equals 7 cos 30 times by t plus half of a, well, half of a is 0, so that'll be 0. And so that tells me that t equals x over 7 cos 30. And that I'm going to substitute up into here. And then once more, I want the one without v, so s equals ut plus a half a t squared. And substitute that in, s, that's y, equals u, which is 7 sine 30, times by t, which is x over 7 cos 30, and then that'll be plus a half a, but a is minus 9.8, so that'll be minus 4.9, and then times by t squared, that will be this bit squared, so that'll be x squared over 7 squared cos squared 30. I can simplify that. Y equals, that'll be x times, or 7 and 7 will cancel out, so that'll be x tan 30, and then it'll be minus 4.9 x squared over, that'll be 49 cos squared 30. Well, I can work those out as numbers. That'll give me y equals 0.57735 x minus 0.1333 x squared. So I've got x and y in terms of t, x is that's in terms of t, y is also in terms of t, and actually just realised I haven't expressed y in terms of t, so I should have here, again using this formula here, so I should get, I'll do it in red so you can see where it comes from, there. I'm going to get y equals u, which is 7 sine 30 times by t, and then I'm going to have minus half of a, so that'll be 4.9 minus 4.9 t squared. So that's done it. Did say it, should have put it in. And then I go on to part 2. I've got to calculate values of x when y equals 0.6. So I'm going to put in y as 0.6 here. So that'll give me 0.6 equals 0.57735 x. I obviously keep more stuff in my calculator. Minus 0.1333 x squared, and I can make this quadratic, well, it is a quadratic, but I'll put everything onto the left hand side. 0.133 x squared, that's adding that, take away 0.57735x, and 0.6 already over that, so plus 0.6, and that now equals 0. And that's just quadratic in x, so I use quadratic formula, so I get x equals minus b, so that'll be plus 0.57, etc. And then I'll work out that. That will give me x equals 2.598007, or 1.732050 from a quadratic formula. Part 3. Find the direction of motion when the particle is, and y is 0.6 and it is rising. Okay, well obviously I work out the velocities. Obviously the horizontal velocity doesn't change at all, so it's still 7 cos 30, and I want to work out the vertical one, so on the right hand side of the page with Stuva, and we've got s we're told is 0.6, t we really don't care about. Initial velocity is 7 sine 30, which obviously equals 3.5. And v, that is what I want to find, and a is minus 9.8. So I want the one without a t in it, so that'll be v squared equals u squared plus 2 a s, that's plus. So it gives me v squared equals 3.5 squared minus 9.8, that's 19.6, times by s is 0.6, and that equals 0.49, and so v equals plus or minus 0.7, and obviously I want it to be, it's going up, so it's going to be plus 0.7, so I'll do it in red again because I'm running out of space. That is 7 cos 30, and that is 0.7, and there's our two velocities, and we want the angle, so we'll have this angle here, so let's call it theta, so tan theta equals opposite over adjacent, so 0.7 over 7 cos 30, which equals whatever it equals, but theta equals 6.586775 degrees, and that is to the horizontal. And as always, you should round to 3 significant figures. I haven't, so you can check the answers. And that's question 5 done.